Alright, so I'm Alex, and this is my original design that we came up with in one of the first lessons that we did the Vex Robotics. It's quite similar to the complete design that we came up with together. There are a few similarities, such as the color sensor here, which was implemented as a larger camera to help. In my original design, it was to help with detecting where the robot wanted to be going. In the current design, it's supposed to be to help the arm know when it needs to move around.
But also, we know where everything's going to be now, so you changed that. We didn't need that anymore, did we?
Yeah.
Is that that was part of what we found as we went, wasn't it?
Yeah.
Good.
Here you can see that there's a sort of basic claw. We did go with a claw for our final design. It's not here connected to the robot at the moment, but that's what we did.
And that's covered in a different video?
Yep.
Now, how is that related to the combined robot?
So in the combined robot, you can see that we have a base which is 4 wheels on the bottom with an elevated platform. I suggested the exact same thing in my initial design as well. Another thing that I've been doing a lot of work on is the wheels and how the movement of the robot works, because I'm the driver. One of the problems with our current wheel solution is that because of the wheels, we had to pick between regular wheels, which is this ones, and the omnidirectional wheels, which are these ones. Omnidirectional wheels allow for a lot of maneuverability, but they are quite unstable, so they kind of slide around and they don't stay in the right place where you want them.
You mean they can slide on their own?
Yeah, they slide.
Once you've got them bolted in, they're stable, but they...
Yeah, that's what I meant.
Yeah, okay, good. Yep, understand.
And the normal wheels, they're nice and stable, but they also don't allow for much steering. So we had to strike a balance between having the robot staying where it needs to be when it's moving around, but also being able to steer properly. Mm-hmm. So what we did was we had 2 omnidirectional wheels at the front and 2 regular wheels at the back. This allows us to have a lot of freedom when we're controlling the robot, but it also keeps the robot where it needs to be by not allowing it to slide around by itself.
Good.
Another issue that is still present in the robot is here. You can see there's an axle here, and that's going right through one of these squares, and whenever the robot moves around, it's just kind of wearing down the hole, so it's a lot bigger than it used to be, and it's just whittling down the metal. And we've now realized, a bit too late, that we could have resolved this issue by implementing gears into the wheels. So instead of having just motors spinning the wheels around, we could have used a much larger axle that's not going through one of these holes, and have each wheel driven by a gear instead of the motor just directly doing it. So we would have the motor powering like a chain of gears, and then having like this. So here's the motor, and it's spinning the gear around, and while it does that, it's spinning the wheel around as well. And the plan with that is that it's basically, the wheels are still the same, but it's not damaging the metal, and it's still, because if the metal holes are worn down too much, it'll become unstable, and they'll just be bouncing around in the little hole, which is getting bigger as it's whittled down.
And it's a lot more, you can adjust the speed at which it moves, is that right?
Yeah.
Now, did you want to show this moving with your remote?
Yeah, sure.
Alright, let me just turn it on. I'll take it off the table. Need to hold that for you? Sure. So it's pretty quick. Can you drive it up onto here? Is that right?
Yep.
So I put you on the spot, didn't I?
Oh, don't have to go.
Perfect. Good. Happy?
Yeah, happy.